Hi, my name is Harris Clark, and I'm an associate at Kilby Solutions. I'm here to demonstrate the power of Appian and show how quickly we can build out an application. The application we are going to build today is a life status indicator for our company. The managers want their employees to be able to indicate if they have things going on in their lives that may be impacting their work, so they can respond accordingly. The functionalities we want are 1. The ability for an employee to update their status when they have something going on. 2. An employer alert when an employee changes their status. 3. A report that the employer can access that shows everyone's current status. And 4. A weekly alert to the employer listing everyone who has something going on. I just want to point out before we begin that I'm making this video and doing voiceovers at the same time. It's difficult to do both, so there are several occasions where I slip up speaking and have to go back and redo the audio. Because of this, the timestamps of when the objects are modified vary, but the actual time spent coding is authentic. First, we'll go into the Appian MySQL database and create our tables and views. The first table we'll create is called lind reference data, and it will contain all the reference data for the application. The reference data that we'll be using are statuses, and they have an integer ID, a type, a value, and an integer sort order. The ID will be the primary key, which is its unique identifier. We'll go ahead and populate the table with the data we've already discussed with the client. There'll be 6 different statuses, and as of right now, they will all be type status, and 3 will be of the value OK, and the other will have the value of affected. More information will be populated later, but this is just a base for the reference data. The next table we'll create is called lind user, and it will have 8 different attributes. It will have a username, a life status ID, life employee notes, life manager notes, and audit data, which are created on, created by, last modified on, and last modified by. We put audit data on all transactional data, that is, data used in an application that will be changed a lot. This is just so we can see who created the data and who most recently changed it. And the username will be unique, so we can use it as the primary key. The final structure we need to make in the MySQL database is a user view, which we can create from the user and then edit further. We can take the SQL code generated by the database and copy and paste it into a MySQL validator to get a better look at it. All that I'm doing here is joining one aspect from the reference table, that is the status. All that's really being done here is taking the life status ID from a specific user and looking up the corresponding status in lind reference data and populating it into the view that we have created. This will help when we want to display data later in the project. This is everything we have to do with the MySQL database. From this point on, we will only be dealing with the Appian designer. Here we'll begin by creating the life indication application. As a bit of housekeeping, I'm going to go ahead and create 4 folders for the application. One is going to be comprised of the rules, constants, and interfaces. The next folder will be the Knowledge Center for the application. A Knowledge Center is essentially a folder where all information relevant to the application will be stored. Within the Knowledge Center, we will create a document folder, which will contain all the documents that are relevant to the application. The final folder that we'll create is a process model folder that will store all of the process models for the application. Now we'll go ahead and create the custom data types for the application. Appian allows you to create data types from database tables or views. So since we already created them, this makes this process a lot easier. First, we'll create the lind reference data type, and we need to create a data store for it, and this will be stored in lind reference tables. The next data type that we'll create is lind user, and it, as we talked about earlier, will be stored in a data store called lind transaction tables. And the final data type that we'll create is lind vuser, which is the user view data type. And we need to make sure to introduce a primary key since we forgot to do it when creating the database. Now that we're done with creating the data types, we need to create constants for data types so that when we want to reference them later, we can just reference the constant instead. So we create one constant for the user, one for the user view, and another for the reference data. Now that we've created the constants, we'll start creating query expressions for each of the data types that we've created. Query expression is simply an expression that we build out to be able to pull information from the database. So in this circumstance, we are creating a query expression that when we call it will pull all users out of the database that satisfy the criteria that we set. The only two rule inputs we are putting in right now are username and minimum status ID. So we can pick by a given username, or we can get all users that are above a given status ID. And the way we reference rule inputs in Appian is RI and then a exclamation mark and then the name of the rule input. The exclamation mark is commonly referred to as bang, so you would hear RI bang username in reference to the username rule input. The last thing I'm adding is paging info. We want a default set so that if no paging info is introduced, then we will have our company standard put in anyway. Now we are creating a query expression for the user view, and since user and user view are so similar, I'm just copying the user query expression and changing the constant that the query expression references to that of the user view, and it's already made. Finally, we're creating the query expression for reference data, and all that we're going to use as a rule input is paging info and ID. the rest of the construction of this is the same as how we created the query expression for a user. Now I need to create two expression rules that are pretty standard across all of our applications. They both deal with the audit data that I referenced earlier. Um, all this expression rule does is populates the audit data. If you just created this data entry, you will be marked as the creator and the time will be noted. And if you're working on it and you edit it, then you will be marked as the person who last modified it and the time will be noted. The second expression rule we're creating is replace null, and it's used by the save audit data that we just created. And all it really does is if you have a null value, it replaces it with a value that you set. Now I'm creating two different groups. The first is the manager group, and it'll be comprised of everyone who has the ability to see employee statuses. So this would probably be HR, and I populated myself in it for testing purposes. And the second group will be Lind admins, and this will be a group that will be alerted whenever a process model fails or if something breaks within the application so that they can act accordingly. Along with the creation of the two groups, I'm going to create two constants that refer to the groups. We like to refer to the constants rather than the groups when we're creating process models and interfaces, just to make everything a little cleaner. Now I'm creating some constants that we've already planned out in the earlier stages of this application build. The first is Lin green to red, and it's 6 hex codes that range from green to red that will act as the color for given statuses. So 1 will be green and 6 will be red, and the middle will be the middle. Now we'll have Lind outlook values, which again are pre-planned values that correspond to the 6 different statuses, and those are the outlooks for each status. And along that same thread, we'll have Lind needs, and the needs are the accommodations that will be necessary for an employee that correspond with each of the 6 statuses. Now I'm going to create an interface for a section header. And this will be used in several other interfaces later in the application. But all this does is create a section header that will be an icon, text, and an optional bar below it, all in the same color. This is something we at Kilby Solutions like to do just to create an aesthetically pleasing and uniform interface style. And I forgot to do this earlier, but we're actually going to change all of the colors in the section headers to our standard Kilby blue. Now I'm going to create the Lind Update Employee Status interface. What this will be used for is for either the employee or the employer to change the status of the employee. The employee will actually be able to change the status and their notes. All the manager will be able to do is see that information and then be able to add their own notes to it. So now I'm just creating a few rule inputs for the interface. We'll have a user, a username, a cancel boolean, and status change, which will be a number. I'm using abang local variables for the creation of this interface. What abang local variables does is allows you to create local variables that only will be referenced within the interface and do not need to be passed in or passed on. So the first I made is local bang query, and that's just getting a user based on the username. Now, local bang old user information uses an if statement. So if the query turned anything back, then it will take that first entry, which will be the information of the user. Otherwise, it will create a new Lind user instance with that username and a default life status ID of 1. And after this, I'm going to create a local bang new user information that is equal to old user information in the beginning, so that at the end of the process, we can compare the statuses of the two, and that will populate the status change rule input, and it will signify how much of a change actually occurred when the employee updated their status. And finally, local bang status options is just querying the reference data that we've already created for all 6 statuses. Now I'm adding a section header that we just created. we like to use section headers as spacers between certain objects in the interface. And now I'm creating a card layout that will be the headers for each of the attributes of the statuses. So the first column is blank, and that will be either a radio button or a check mark. And then the next column is the status, then it's the outlook, and then finally the needs. Just as we created a card layout with 4 columns for the status headers, we want to do the same with each status so that the employee can pick a status and know what they're actually picking. We're going to do this using a for each loop. And what a for each loop is it takes a list of items and executes an expression over each of the elements in the list. In this case, the items we're using are local bang status options, which is the 6 statuses that we've settled upon, and the expression is to create a card layout. The first column that we're going to create is either a checkbox indicating the selected status that the employer will see, or a list of 6 radio buttons with 1 selected, which the employee can then change their selection on. The first thing we do is create an if statement to see if the logged in user is not equal to the username of the current entry. If this is the case, we can assume that the person viewing the entry is a manager. From here, we make another if statement that simply places a check mark at the status that has been chosen. We do this by just asking if the index, fvbang index, references which iteration of the for loop it's on, is equal to the life status ID of the user information. The way we display a check mark is by first creating a rich text display field, and within that creating a rich text item, and within that creating a rich text icon that has the icon value of check. We only pass this rich text display field into the row that has been selected. In the other 5 rows, we simply pass in a value of null, which is no value, and it will not display anything. The other case we have is if the logged in user is equal to the username of the entry that we're looking at. In this case, we want it to be a radio button field so the user can actively change the status. We don't want there to be any labels for the radio buttons, so we input a list with only 1 value, which is null, for the choice labels. The choice values, we use the property function to pull the property of ID from the status option that we're looking at. we only want the radio button that's selected to actually have a value. So right here, what I'm doing is verifying that the status option ID is equal to the ID of the entry that we're looking at. Now I'm defining the save into location, which is the location in memory in which a selected value will be saved into. And that we define to be local bang new user information.life status ID. We want this to be disabled if the logged in user is not equal to the username of the current entry. And we want the width of each card to match the width of the top card so that they will all be laid out properly. And you can see now that the check mark has been placed in the first column, because if there's no entry in the database, then we create one and have the default life status ID of 1. So that's why you see the check mark in the first box. The next 3 columns are a lot easier than the last one. For status, we just simply pull the value from the status option and display that. If you remember earlier, we created constants that were lists of text for both the outlook and needs values. So now all we're going to do is use the fvbang index and index the given value of the array. So in the first row, we'll pull the first value from the outlook values and then the first value from the needs values. The final stylistic thing we're going to do with this card setup is color coordinate them based on the index. We created that constant green to red, and by calling the index from the for each loop, we get 1 through 6 listed from green to red. Now we add paragraph fields for both employee notes and manager notes. We need to make sure to validate that the text entered is less than 500 characters. So we do that using a validation. If the entry is more than 500 characters, the employee will not be able to submit the update until they've corrected that mistake. We save this value into the life employee notes for the current new user information. We also want to make sure this is disabled if a manager is looking at the entry, so a manager cannot change the notes of their employee. Here we're just validating that the length is less than 500 characters. A parenthesis got misplaced in the for each loop, so I just need to figure that out real quick. Now that that problem is fixed, I'm just going to copy the entire paragraph field I just made and paste it right below and make a few changes for it to be the manager notes instead of the employee notes. The only real difference between the two paragraph fields is that the manager notes will only be able to be seen by people who are members of the manager's group and where the values are being saved. Finally, we add a button layout that allows users to either press a button that says submit or a button that says cancel. If the user presses the save button, there will be a few things that happen. First, we will save the new user information into the lind user rule input. After that, we calculate the status change to be the difference between the status IDs of the new user information and the old user information. This will allow us to discern whether an employee has had some good news or bad news. Finally, we add the audit data. And also we add a confirm message just to make sure when a user presses save that they are actually wanting to save the information. We also add a secondary button that's a cancel button, and all that it'll do is when pressed and confirmed, save a value of true into the rule input cancel. This will be used later in our process model to decide what we do with the information. And now the update employee status interface is completed. Now we create our next interface, which is the employee report interface. This will just be a data table that will display all of the employee statuses. We start with the section header that has a group icon and a label of employee life indication status. Below this, we enter in a grid field with specific columns. The data we'll be using is just a query of the entire user data table. The first column in the grid will be the name of the user, and we use a built-in Appian function for the value that is display user, and all we input is the username, and Appian does the rest. This next column is a little more stylistic. Instead of just writing down the number of the life status ID, we use an icon of a circle and color it based on the green to red constant that we created earlier. It provides an easier way for the managers to discern who has what going on. The next two columns are simply pulling the employee notes and manager notes from the specific row. We do this just by using the property function for the value. The last column won't have a label. It is supposed to be a link that will allow the employer to go in and add notes to an employee's status. Since we haven't created the process yet, I'm going to leave the actual link blank, but the value that it will have is just a rich text icon of a pencil. Now we're done with the employee report interface. Now all that we need to do is create a few constants, a report, a few process models, and then add the last little bit of functionality into our interfaces, and then implement all that we've created into our site, and we'll be done. So now I create a report for life indications that links to the interface that we just created. And along with that, I'm going to create a constant that refers to the report. Here is an HTML template for an email that we want to send out. I'm going to upload it to Appian, but all it is a template that provides the HTML formatting for the email. And wherever you see the 3 pound signs and then a word and then 3 more pound signs, that will be read by Appian as an input that we can put information into. Now we're going to go ahead and create our first process model called Employer Alert. And it'll send an email to an employer when an employee changes their status. So first we change the alerts group to admins and make sure that after a day we delete any processes. So we create a process variable called user, which is of type lind user, and it'll be a parameter. We also create a change process variable. So now we input a send email node, and that will do most of the work. So we make it from the process and send it to all of the managers, which we've already made a constant. The subject will be life indication update for, and then input the employee name. And then we upload our email format document as the HTML template for the email and add the inputs that we've already created for it. And we add a terminate process on the end node and change the swim lane to be system and have it run by the process model. Now we create probably our biggest process model, update life status. And this will be the process model that allows employees to change their status. So first, again, we change the alerts group to lind admins. And now we have the process variables. So we have a user. We'll have a status change integer. We'll have a username. And we'll have cancel as a Boolean. Now we create 2 swim lanes for this process model. The first is going to be employee or manager, and it'll be assigned to whoever initiated the process, referred to as PP bang initiator. And the second swim lane will be system, like the one we had in the last process model. The first thing we add is a user input task, which will be update employee status. It'll have a few pieces of data. The first will be a user, and we pull that from the process model. The next will be cancel. And then we'll have username. And finally, status change. Now we go into the form and pick the interface that we want to be augmenting these values that we just created. And so we do the update employee status. We also want to set a timer, so if the form is idle for 60 minutes, it'll automatically terminate the process. We don't want any forms to just be open in the processes to just be sitting around. Now we add an XOR node, which is just a logical node. So it will ask if cancel is true or false and act accordingly. If cancel is true, it'll terminate the process because we're not supposed to write anything to the database. And if it's false, then it will go to write to the data store entity and write the user status into the database. Now we need to mark the data that we're going to be inputting into the data store, and we need to identify that it's going to be of type lind user. And then we need to specify further what the user is actually going to be. And see here how we have PV bang user, just like how we had RI bang and local bang. PV bang refers to the process variables outlined in this process model. So now this will write to the database. And now we just need to deal with sending an email if the employee has indicated they have something going on or something has been resolved. And we connect this to a sub-process, which is the process that we've already created. So what this XOR node is going to do is see if the status change is greater than 2 or less than -2, which we've already decided to be the indicator of something getting better or something getting worse. So if the status change has not changed that drastically, then no email will be sent. Otherwise, we need to send some information into the sub-process before we begin. So first we go into our sub-process and access the employer alert sub-process that we already made and align the input variables so we know the information is moving properly. Now we just need to add some chaining between nodes to make sure that the process moves cleanly, and add a terminate process to the end node. And now the update life status interface is complete. We also want to create a constant that refers to that interface so that we can refer to it in other pieces of the application. The first place we're going to refer to it is in the employee report interface. And instead of the process model being null, it's going to be that status update process model. And we're going to pass in the username as one of the parameters. The second place we're going to put it is in the KS portal that you haven't seen yet, but we're simply going to add a box like the ones below with a different link, and it will say life indication. And it will have the update life status link. And we also need to make sure to add the employee report into the reports page so that the managers have a place to access this information. The final thing we're going to make is a employer weekly email process model. And what this is going to do is send an employer an email once a week saying, these are the employees that have stuff going on. Click here to see more, and it'll have a link to the report. Again, we need to change the alert to the admins and delete the processes after 1 day of inactivity. We need 2 process variables. One's going to be a name of users, and the other is going to be a list of users. Now we're going to add a script task to get all the users with life status IDs greater than 2. And the way we do this is by making a query in the output and inputting the min status ID rule input to be 3. So anyone with a life status ID of 3 or greater will be returned. We make sure to store this as the target users. Now we add a XOR gate to see if there are any users. So if there aren't any, then no email will be sent to the employer. We do this just by seeing if the list of users is empty or not. The second script task is taking the list of users and generating their names from it. This will be used as part of an input into the email, and it will just be a list of everyone's first and last name. Finally, we need to set up how the email is sent. So again, we make it from the process and send it to the managers. The subject will be weekly life indication update. We use the same email format template. Inputs that we've already settled on as the values. Now we hit a terminate process at the node, and we see that there's a target missing in the second task. You have to make sure to add a target for each of the script tasks you use. We need to make sure not to forget that this is going to be a weekly occurrence. So we set a timer for the start node that will be weekly on Monday mornings. So now we can look at what the application actually does. So on the Kilby Solutions portal, you can click the Update Life Status link and change your status, write some notes, and submit it. Conversely, as a manager, you can go to the reports and view the report and see that I have indicated I have a 4, and then add your own notes to that entry. I hope you've enjoyed this video. Start to finish, this app took less than an hour to build, and I hope this has demonstrated the power of Appian and the efficiency of Kilby Solutions.